Hi everyone. This is the first video for my channel, and this video will be talking about quadratic graphs and their properties from the book Algebra 1 Common Core, which is math for grade 9 or grade 8 in the international American schools. So let's get started this lesson. So this lesson will be about the objective graph quadratic functions. So we need to graph the quadratic function of the form y equal ax squared or y equals ax squared plus c. Let's get started and discuss about the quadratic functions first. So quadratic functions first, it could be on this form ax squared plus bx plus c. But basically, we can just say it is a polynomial of the degree of degree 2. It is a polynomial of degree 2 as we discussed in chapter 8. So this is the meaning of a quadratic function. So if I say y equals to x to the power 2, this is a quadratic function or quadratic equation. Y equals to x2 plus x. So this is also quadratic function. So if we have any form and the greatest power in the form that I have is 2, that means it's a quadratic function. So quadratic function, it is written on the form, on this form. So sometime I don't have this, which will be like this form, or sometime I have only this part, but this is the most important part that will make it a quadratic function. We can say about this form, we can say that this is standard form of a quadratic function. So this is a standard form of a quadratic function, and here is some examples. So the simplest quadratic function, which is this form that I wrote it here. So this is the parent, and which is parent function for the quadratic function. So quadratic parent function, which is this one. We can graph it like this, which is U shape, on the U shape, which is what we call it parabola. So this is a parabola. So the parabola, it has special properties, which is symmetric properties. I mean, this side, if we fold it around the y-axis, we can have this side, it's exactly the same as this side if we fold it, or we can say if we flip it around. So this is the idea from this part. Let's move on. This will help me to graph it. I will try to find only one side, then I will flip it around to get the other side. Then also we have more properties, which is we can say about this point that we have it here, which is the one that in the middle, that will be, I mean, on the it will be on the axis of symmetry. I will call this point vertex. I will call this point vertex. And this point will be sometime minimum and sometime will be maximum. When this point will be minimum and when this point will be maximum. It will be minimum if I have a greater than 0. I mean, if it's positive, I mean, if I have y equal, for example, x to the power 2. Directly, the graph will be like that. But if I have the graph equal to negative, that's example, x to the power 2, so it will be maximum. Why it will be maximum? Because the graph will be something similar to this. So this is the vertex. So the vertex could be minimum and could be maximum. Let's see the first problem. So in the first problem, we need to identify a vertex. So once we want to identify the vertex from this graph, we can easily find it like that. This is the vertex. I can read this vertex in 2 by saying this is 0 and 3. So it's 0 and 3. So the vertex at 0 and 3. All right, so it is also, we can say this is a maximum. It is a maximum. This is the greatest value for this function, so it is maximum. While this one, we have, this is the vertex, and this vertex, it's what? 1 and -1. So it's a 1 and -1, it's a minimum. It's a minimum point. This is the minimum for her. If this is upward, you can have it, you can have directly, if this is open, let me say here downward, we can say is a maximum. If it's open upward, you can say it's a minimum. It's like the opposite. If it's open up, that means it's a minimum. If it's open down, that means it's a maximum. We can easily have this exercise or just as an application for the first problem. What is the vertex of the graph? At the right, is it minimum or maximum? We can have it, it's open upward, so it's a minimum point. And my vertex is, so it is a minimum, and the point or the vertex is, let's read it, -2, -3, -2 and -3. So this is the point. Now, let's move to the graph. The graph, the symmetric of the graph will help me to graph the quadratic functions, which is on this form. However, we will gonna use this form, which is, we will gonna use a transformation for this form. Let's do it. So here we have this one. I'm going to find only 3 points. I will start from 0 because 0 is easy to find. Also, I will find something, I can divide it by 3 so I can have easy number. I'm going to use the 3 and I will use 1 and I will use 3. Or let me use 3 and 6. Why I'm using these for x? Because I can use this fraction and remove it, which will be easier for me in the calculation. Let's do it. So if I substitute 0 here, y will give me y, which is equals to 1/3 x to the power 2, and the point xy will be, so 0 and 0, it will be 0. 3 to the power 2, 1/3 times 3 to the power 2, it will be 9. So 9 times 9, 9/3, it will be 3. It will be here equals to 3. So that is equals to 3. So the point will be 3, 3. Here it will be 0, 0. And here we can say 1/3 times 6 to the power 2, which is 36. So that is equals to 12. So it will be 6 and 12. Now, since the coefficient of x to the power 2, which is this form that make it a quadratic, since this one positive, for sure the parabola will be open upward. So it will be open up. Now I will use the symmetry that will help me. I'm finding only the right side. So I will keep this 0. I will keep each square 3. So that is a 3. So 3 plus 3, 6. Then 9. Then we have this one plus 3, it will be 12, and so on. We can just write it. Here we can keep them 1, 2, 3, 4, and so on. I just used 4, 5, I need 5, and 6. Let's sketch these points. 0, 0, 0, 0 is here. Now, 3, 3, which is 3 and 3, which is here. 6 and 12, 6 and 12, which is here. Now, this is my first side, which is going like that. Now reflect this one to the other side. So take this point, reflect it over y-axis. Keep in your mind, if you have this form, I mean nothing plus nothing is 0. That is mean the axis of symmetry is the y-axis. So reflect this over y, so the space here should be equivalent to this space. So this is the, if you fold this one, you will get it here. Now this one, if you fold it, you will get it here. So 1, 1, 2, 3, 4, 6. Here, same thing. Now this is your graph. This is easy and simple. You just can see the how wide is this one. Now let's do this one. So we have, since this is negative, for sure I will imagine in my mind, it will be like this. The graph will be like this. Why? Because it's negative. So it will open down. It will reflect down over x-axis. So let's take 0, 1, and 2. Why we are taking these 3 points? Because we will find only one side, then we will reflect it to the other side. We will use the axis of symmetry or this property that will help me. So this is x and this is y equals to negative 3x squared. So many students, once they substitute sometime, this is 0. 0 times anything gets 0. Now once you multiply by 1, it will be negative 3. Once you substitute this one here, so it's 2 to the power 2, it's 4. 4 times negative 3, it's negative 12. Let's graph these points. Again, I'm going to use each square. I will represent each square 3. So that is negative 3. That is negative 6. That is negative 9. Now this is negative 12. That's what I need. Now let me sketch this one. 0, 0, it's here. As I said, if you don't have something like this plus a number, this number will play as moving, shifting up or down, left and right, and so on. I will discuss with you this part later at the end of this lesson. So here is the point 0, 0. Here is 1, it will be negative 3. So this is my point. And we have 2, it will be negative 12. So this is the point. Again, using the symmetry of this part, it will be here, the point, and it will be here. So this is your parabola. That's how your parabola look like. Definitely in your notes will be better and more organized more than me, because you will do it on the notebook. It will be easier. Now let's move to problem 3. Problem 3 will be talking about comparing width of parabola. Let me tell you a simple thing. I have 2, I will give example to make it easier. X to the power 2 as the one that we did. Or if we have, for example, y equals, that's what we did, 3x to the power 2. Both of them will be open up, both of them positive. Let me compare between them. So if I will look at this one, once this one gets smaller, that means the wide for this side will be bigger, the opposite. Like this one will be, the wide will be bigger than this one. Why? Because the coefficient of x squared is smaller than this one. So let me give you example. Without graphing, we can directly classify, or if we have match, will help us to figure it out. So if we have these three functions, we need to graph them. Here in this book, they use the graph calculator, but we don't need to use the graph calculator. We can graph the first one. We directly know that this graph will be open down. And how it will open down, once we substitute by 0, it's 0. Once we substitute by 1, it will be 4. So this will be -4. It will be here. This is 1. I'm just approximating. Once we have 2, it will be 4, it will be 16. So somewhere it will be 16 down here. So this is the, we can say this is the point. So this is this side. I will try to graph them. I can just show you the graph easier. Now, this is the graph for this one. You will notice that this coefficient is smaller than this one. The absolute value for f, definitely, we don't just compare between them with that sign. We have to take the absolute value and directly think about it, because the negative sign will play open up or down, while this as a value, this number as a value will play with the wide. So if this number will be smaller, so it will be, the wide will be bigger. Look at here, this one, it's a 1. The wide will be smaller than this wide. So this is the idea from this part. If we order them, if we order the wides for these graphs from, let's say, if we order them from greatest to least, we can say this is the wider, this is the biggest one, and then we have this one, 2, and then we have this one, 3. We can just think about these numbers, the coefficient 1/4, 1, and -4. This is the idea from this part. We can have also exercise. We can, let me write the exercise. Got it for this problem, for which is that, say, if we have y or f of x, it's same thing, -x to the power 2, and we have 3xy equals to 3x to the power 2, and if we have y equals to -1/3 x to the power 2. I'll directly think about the absolute value. I'm not worrying about the sign. The sign will just play with open up or down. So the widest one, which is 1/3, because the absolute value for this coefficient is the smallest one. So this will be the widest one. Then we have this one because it's 2. Then finally, the smallest wide, it will be this one, which is 3. And you will graph them by the way that I did before a few minutes. Now, in this problem, we just will play without graphing, wasting the time. We will graph only this one. If we graph this one, what is the change that will be on this? If we have the graph, for the basic function, which is y equal ax squared, if we have it by using this red color, what is the change that will be for this one, +3? It will be a vertical change. You will move all this graph 3 units up. If you have this one negative, you will move the graph 3 units down. This is the idea. So the answer for this one, it's what? Shift 3 units down. Shift 3 units down. You might ask, maybe there is something coming to your mind. We said about negative. When I will move the graph left or right, I will tell you, you will move the graph left or right if the change inside this x. I mean, if you have y equals to 2x plus 3, all this to the power 2. Like the change for this one, inside the power plus 3. In this case, you will move the graph down 3 units. If you have y equals to 2x minus 3, all this to the power 2, in this case, you will move the graph not down here, you will move it to the left. This one minus 3, you will move it to the right. Minus 3, you will move it to the right. So this will be moving to the left. This will be moving to the right. If the change outside like this, outside this parent function, if the change outside, you will move according to the sign that you have. If it's a 3 plus 3 units, you will move up. If it's minus, you will move down. Let me give exercise. So we have this one. Basically, we know that this graph, I will graph it by using a specific color. So I will graph it by using red. So I already know that this will be 1, 1. This will be 2, 4. And so on. 3 and 9. So this is the basic graph. I will reflect them. So this is the graph for this one. Now, what is the graph for this one? I'm not wasting my time and calculating other points or other things, no. Since this is -3, exactly the same function that I have, and there is change outside this x, that means I will take this graph, I will move it down 3 units. -3, move it 3 units down. So take this point, just move them 1, 2, 3. Just move your point. Here, this is the vertex, move it 3 units down. 1, 2, 3. Take this point, move it 1, 2, 3, move it down. And the last one, move it also down. Reflect them now. Take this one, just reflect it. Reflect your point. So this is the new graph. Without calculating a new point and so on, without calculating. If this is a plus, you will move it up. Okay, you might ask, okay, what about shifting left or right? I'll tell you, shifting left or right, the change of this graph, if you have y equals, for example, x to the power 2, the change for this one, if you have it, y equals to x minus 3 to the power 2, y equals to x plus 3 to the power 2. Outside. What is the change here? The change here, you will move this graph in red 3 units to the right. So you will take this one, you will move it 3 units to the right. You will move this one 3 to the right, then you will graph it by using exactly the same way. What about if this is plus? If this is a plus, you will move 3 units to the left. Make sure that you distinguish the difference between this formula and this formula. Both are quadratic functions or are quadratic equations, but it will be the change for them, it will be like that. let's move to the last problem in this lesson, which will be about the applications. So let me show you, if I have applications like this and a corn drops from a tree branch 20 feet above the ground, the function which is given by this one gives the height h, which will be represented by h. As I said in my previous lessons, the h will be dependent variable, which will be in the place of y, and t, which is the time, and the time always independent variable, which will be in the place of the x. Now, what is the graph of the quadratic function? We need to graph this one. So once we make our table, we cannot have, keep in your mind, you cannot have negative values or negative numbers. So you will take some values of t, which is time. You cannot have negative, you cannot go back to yesterday. You cannot go back to even today, before 1 second. You cannot go back, so you cannot have negative values for the time. You can just take these simple points, 0.5, you can have 1, and finally I will just take this point to answer to graph this one. So if I substituted this 0 here, I will get immediately 20. If I substitute it by half, I will get 16. If I substitute it by 1, I will get 4. Then finally, I will get minus 16. So let's graph this one. Now, if I represent this one, I will make this is half, this is 1, this is 1.5, this is 2. All right. Now I will make each square here 5, easier, and this is 10, this is 15, and this is 20. So once I have 0, the value will be here. For sure, this will be part from the parabola, and it will open down because it's negative. It fall down, it's going down, so yeah. So if, as I said, the corn will drop, and this is the time, and this is the represent the height. So once it's already here, it's on the 0, that means the corn on the tree itself. So the corn, it's already on the tree itself. So here it's 20 feet. So it is 20 feet. So if, let's say, this is a corn, I'm just graphing anything just to explain the idea. So at 0 time, it's already on the tree. So then after half minute, it will be 16. It will move here. 16, if the height 16, after it will be here. Then after 1 minute, it will be close from the earth, and it will be 4. Finally, we have 1.5, it will be minus 6, which means underground. So that means we can cancel this one, which is impossible, how it will be underground. So we can just say it will be like that. Before 1/2, it will be here. We have to stop, because logically we cannot have it under the ground. We cannot have the corn under the ground. So I will stop here. Then this is the graph. Now I will answer, at about what time does the corn hit the ground? What time? You can just say after 1 minute and in less than 1.5 minutes. So this is the idea from this part. You can just do exactly, this is the professional answer. Now you can do exactly the same as I did here with this problem. Make sure that you practice it. Thank you for watching, and this is the end of the lesson, and bye. Hope you like it, and bye.